Okay, so let's go ahead and do a couple of problems. So here we want to verify the following trigonometric identities. So we know that this is an identity, and we want to show that that the right-hand side and the left-hand side are both equal to each other. So remember that you always want to start with the most complicated side. So in this case, it seems like we can do way more with this guy, the left-hand side, than we can do with the other side. So let's show that our left-hand side, so this is where we're going to start off. We're going to start with our left-hand side, which is tangent of theta, cosine of theta. We want to show that this is going to be equal to the right-hand side. So we got to do a lot of algebra to try to figure out that this is actually equal to sine. So the first thing that I can kind of think about is that cosine, I really can't do anything with the cosine because the cosine doesn't really have an identity. Can I try to transform the tangent to something? Well, if you look at our trig identities, well, we know that tangent is equal to the sine theta over cosine theta. So I'm going to replace the tangent right here with sine theta over cosine theta because that's what tangent is equal to. And then I'm going to do nothing with the cosine. So the cosine is going to stay by itself. Now notice what happens to the cosines. The cosines cancel each other out. And all I'm left with is just sine of theta, which is just equal to the right-hand side. So at that point, we have finished the proof. We basically have verified that the left-hand side is equal to the right-hand side. Usually, typically, what I like to do is that I like to draw like a little box, okay? And just draw a little like a little box and then fill it in. This just means that I have finished the proof. I have proven that one side is equal to the other. It's just basically mathematics lingo. So you can just so please just write this down. Just a little box with the with it filled in. Just that lets me know that you are done with the proof. Okay, so now let's try this guy. So clearly in this case, the left-hand side again seems to be the most complicated part. Because the cosine squared, I mean, we can do a little bit of it, but I mean, I feel like it will be easier for us to work with the left-hand side. Of course, you can work with the right-hand side as well. So starting with the left-hand side, 1 plus sine x, 1 minus sine x. Now let's go ahead and just try to do a couple of algebra. So clearly here, something that we can do is FOIL everything out. So FOIL the first guy is going to be 1. Then this guy is going to be minus sine x. The next guy is going to be positive sine x. And then the last guy is going to be negative sine squared x. Now notice that the middle terms are going to go away, which is going to be 1 minus sine squared x. Now what is 1 minus sine squared x equal to? Well, if we remember up here, what did we say 1 minus sine squared x was? So see how I was rewriting this Pythagorean identity? We can see that 1 minus sine squared x, which is this guy, let me put it in a different color. This guy, 1 minus sine squared x, or 1 minus sine squared theta is equal to what? It's equal to cosine squared theta. Okay, so this guy is just equal to the cosine squared theta. Well, I'm going to write x because we're using the variable x. Okay, so see how I said that we have to be able to use these equations to be able to or the rewritten form of the Pythagorean identities to kind of have what we want. So at this point, cosine squared theta or cosine squared x is just equal to the right hand side, and that concludes the proof. So we would just finish it like that. Okay. Now, could you have done it the other way? Of course, you could have done it the other way. If you wanted to start off with the right-hand side, cosine squared theta, or cosine squared x, there's not a lot of things that you can do with this, but we know that cosine squared x, right, is equal to 1 minus sine squared. So 1 minus sine squared x. And then here we can factor this guy out as 1 minus sine x, 1 plus sine x. And this, again, is equal to the left-hand side. So you don't need to prove both of them. You can only just prove one. So you could either have done this guy or you could have done that guy. Okay? So it really just depends, whichever you feel more comfortable with. But usually working with the hardest side is actually the ideal way to do it. Okay. Now let's do this guy. So let's say we wanted to do secant x is equal to tangent of x plus cosine x divided by 1 plus sine x. Okay, so here you have many different options. One of the things that I feel is a little harder to work with is going to be this guy, or the most complicated side. So I'm going to start off with the right hand side. So right hand side is equal to the tangent of x plus the cosine of x over 1 plus sine x. Okay, so at this point you can do many different things, okay? So one of the things that you can do is I can start off by changing the tangent into sine and cosines if you want. I can see a 1 plus sine x, so I can maybe multiply by the conjugate as well. It really just depends on what you want to do. You can go, there really is not one way to do this problem. There's many different ways you can do this. What I'm going to do is I'm going to work with a tangent of x. So I know that tangent is just sine x over cosine x. That's just by using one of the identities. Then I have the plus cosine of x over 1 plus sine x. Okay, so now I have two things being added together, so two fractions. So what I'm going to do is find the least common denominator. This guy, I'm going to give it a 1 plus sine x to both top and bottom. And the other one, I'm going to give it a cosine of x. So all I'm just doing is I'm writing, finding the least common denominator, okay? So on the top, I'm going to have sine of x, 1 plus sine of x, divided by cosine of x, 1 plus sine of x, plus, then on the top, I'm going to have cosine x times another cosine x, divided by, we have the cosine x on the bottom, and also the 1 plus sine x on the bottom. So I can distribute this guy out. Notice that they both have also the same common denominators, so I can just write it as 1. So I can just write cosine of x, 1 plus sine of x. So on the top, when I FOIL that out, I'm going to have sine x plus sine squared x. Then I have a plus cosine squared x. Okay. Alrighty. So now what you can do, you can see that this guy right here, this guy, that is just equal to 1. So what we have is sine x plus this guy, sine squared x plus cosine squared x. That's just a Pythagorean identity, right? It's just that these two are just opposites to each other, okay? Or the same, I mean, it doesn't matter. Okay, so that guy is just going to be 1 plus 1 divided by, so you have a cosine x on the bottom, and then a 1 plus sine x. Notice that the top and bottom, this guy and this guy are basically the same. So those you can cancel out. So now I just left with a 1 on the top divided by cosine of x. And what is 1 over cosine? 1 over cosine is equal to secant of x. Okay, notice that this guy is now the left-hand side. Okay, which means that we are now have finished this proof. Okay, so this one was a lot more involved. You had to do more algebra, more combining like terms, and using the identities that we've learned in this class to try to plug them in whenever we can. Okay. All right, now let's do part D. Okay. So part D, what you want to be able to do, it says you want to find this guy and you want to think conjugates. Okay. So when I think of a conjugate, what I really am looking for, the way that you kind of know that you want to do a conjugate, you want to look for these guys. 1 minus sine x, 1 plus sine x, 1 minus cosine x, 1 plus cosine x. So whenever you see these guys here, it should kind of give you a hint of like, maybe a conjugate might work here. Okay. So here, notice that I could start off with whichever I want. I could have done a secant x and a tangent x if I wanted to, but I'm going to go ahead and just use this guy. So I'm going to start off with the left-hand side. The left-hand side is going to be cosine of x over 1 minus sine of x. So I'm going to start off with that guy. Could have done the other guy also. So, but here I would just want to use the conjugates. So I'm going to multiply this guy out. And so the conjugate of this guy is going to be 1 plus sine x. And whatever I do to the bottom, I also got to do to the top. So think about kind of like we're multiplying it by the least common denominator, kind of. All right, so on the top, I'm going to be left with the cosine of x times the 1 plus sine x. And on the bottom, I'm going to have 1 minus sine x, 1 plus sine x. All right, so let's go ahead and try to FOIL everything out. So on the top, I'm going to have a cosine x plus cosine x sine x. On the bottom, you're going to have 1. When I distribute that out, you're going to have plus sine x minus sine x minus sine squared x. Okay, notice that the bottom parts, this middle guy is going to go away. So we're left with cosine x plus cosine x sine x divided by 1 minus sine squared x. So notice that in the bottom, I can just use the Pythagorean identity because that guy is just cosine squared x. You're going to have cosine of x plus cosine x sine x divided by this bottom part right here is just equal to cosine squared x. Okay. Now what we can do is that we can kind of divide this lonely denominator to each of these terms. So what I'm going to have is cosine of x divided by cosine squared x plus cosine of x sine of x divided by cosine squared x. So notice that I have 1 cosine on the top, 2 cosines on the bottom. One of them is going to cancel out the other one, so you're just left with 1 on the top and then a cosine of x on the bottom. This guy's going to go away, and I'm left with 1 cosine on the bottom also. So I'm going to have plus, I'm going to have a sine on the top, and then I have 1 more cosine on the bottom. So then finally we have 1 over cosine. 1 over cosine equals secant of x. And then sine over cosine gives me tangent of x. Okay, and that's basically my answer because this guy now is equal to my right-hand side. Okay, so that concludes the proof in this case. Okay, so could you have done the other way around? Of course, you just have to, it's kind of like if you think about it, you're kind of just doing everything in the opposite way. Okay, so that's basically what it is. So here are some examples using the Pythagorean identities and just some of the basic reciprocal identities. So, and then later on, I'm going to show you guys a couple more identities where things can get, that will be a little bit more useful.